Good afternoon, everyone. Right, so we've had a lot of questions that we've got from many of you on the Pigeonhole, and the way we're going to conduct this discussion is I'm going to pick up questions from the Pigeonhole, and we're going to get our panelists to talk about some of those questions. Now, if you have additional questions now, I believe you already have the URL to the Pigeonhole. You can add them, and I get them live here as the panel goes on. So you can add additional questions. You can upvote questions if you find particular questions you're dying to hear the answers to. Okay? So I really don't need to introduce our panelists since you have heard from them over the last couple of days quite a bit. But what I would like to do is to go through and allow each of the panelists to tell you a little bit about their background and what's the kind of work that they do. Okay. So maybe we can start with the problem.
Thank you. So my name is Roland. So I'm an assistant professor at SUTD in Singapore. And my research work is mostly on swarming systems. I study them from the perspective of physics as well as actual implementations in swarm robotics. So I take great pride at doing everything from computer science, computational science, all the way to actual implementations in hardware and making swarm robotics. Yeah.
Hi, my name is Arkan. I'm a senior lecturer in Singapore Polytechnic. I'm also the one arranging you this pool and the hall and everything for free. Past 6 years, you guys see me at the background, but yeah, thanks to me, please. We are having this pool. I don't know whoever designed this complex, really the architecture foresee there will be underwater robotics competition is going to happen in Singapore one day, and they make an excellent place. Okay, let's talk about me. My background is in computer vision and in computing. I've been in industry working as an electronic engineer as well before stepping into teaching and academia. I have about 6-year industry experience, which involves designing products and delivering to the customer level. So I've been through a lot of stress when I was young as a fresh engineer. In Singapore Polytechnic, I'm mainly involved in teaching and also involved in programs that benefits our students to better prepare them for industry. These programs like multidisciplinary teaching, entrepreneurship programs, and so on. So this competition is also interesting for me because it encourages our students to learn more about engineering and become multidisciplinary.
Besides doing the OES job, which I'm now assistant to the president of OES, no longer treasurer, but don't worry guys, I'll still get you money someday. I know what you want. My work in the oceanographic field actually came out of the military industrial complex before that, doing optical systems. Has been doing ROVs, quite a number of AUVs, and then the last number of years a series of instruments, laser Raman in particular, currently working on nanosecond chopping and picosecond chopping of lasers for reduction of fluorescence. And then I've done closed loop control instrumentation to create CO2 pH changes in the oceans for scientists.
Hello again. My name is Hayato Kondo from Tokyo University of Marine Science and Technology. I'm mostly working on research and development of the AUV related system and also sensors and also ACOM stuff. And education things. I'm teaching also. The university is originally mercantile marine, so I go out the river to teach how to row in the cutters twice in a week, once in 2 weeks. Thank you.
Hi, I'm Tom Curtin. My visit here is a great pleasure because I'm sort of closing the loop where I started my first kind of career in oceanography was at Fisheries Research Institute in Penang, where I worked for 2 years and did a lot of surveying in the South China Sea. And since then, besides being on a university faculty, I spent quite a few years at the U.S. Office of Naval Research developing a lot of different underwater vehicles, mostly a whole class of underwater gliders, what you may have seen, and some powered vehicles. And we spun out companies like Bluefin and Hydroid, which is now part of Kongsberg, and been quite successful developing new classes of small vehicles. And so I'm still dabbling in it in addition to the competitions.
All right. Thank you. What we're going to do now is we're going to go through some of the questions. And I think one of the big question that I have here on the panel is what are some of the specific fields of research in underwater robotics where innovation will lead to a major disruption in development and research? I think it would be nice to hear the views of the entire panel on this question. So, who wants to start? All right, Roland, it is.
I like that too. No worries. Okay, so I'll go first. Actually, I did my homework. I hope all of you students are doing your homework. You see it in SURF. What I mean by that is I read it, like I think it was a week ago, there was a very good article in the new journal called Science Robotics. I don't know if you guys are aware of this. The journal Science has now a new journal dedicated to robotics. And there is there was an article written by all the editors of that journal where essentially they have been describing what they foresee to be the major breakthroughs in the 5 to 10 years in robotics. So one of the two things that actually caught my attention, they are related to my work, so I'm completely biased here. But I do believe that given the extent of the environment underwater, like the great depth, the great spaces, you need more than one unit, right? You saw that coming. I truly believe in swarming in any form. I don't know exactly, we know the challenges because you're moving in 3 dimensions. The communications are very challenging underwater. So right, we still haven't figured a solution to that problem, but anyway. So I do believe that swarming can really help for solutions underwater. As I said, one of the key challenges performing, if you want to achieve swarming, you need communication, effective communication in a way or another. And communicating above water is extremely easy, right? It's very, very effective, but underwater is a big challenge. Whether it's acoustics or maybe using lights, laser, that I don't know, but this could be I think one way to achieve great progress. Another one, I think it's related to computations and artificial intelligence. Can we somehow bring, neural networks, computing inside vehicles that are underwater in order to perform some tasks? That I think is another, interesting aspect, and I would not be surprised to see some developments in that in the coming 5 years. And I'm saying that because nowadays, all these single-board computers like Odroids, BeagleBones, you name them, they are extremely powerful and they can easily be embedded into those systems. So we now have access to a lot of computational power. Why not having a GPU on board and performing neural networks, artificial intelligence, machine learning on the fly? Yeah, that's my contribution. You see, wireless is not good, huh?
Well, it is always, even on the land, communication is difficult. Underwater is hopeless. So the future disruption will be if we can really manage to communicate underwater well. That will make our control a lot easier. Right now, many of you noticed, once you leave your robot on the water, it's completely hopeless. You don't know what's going on. Any technological development in this area will be really disruptive. Then you can go and explore ocean a lot quicker and better, right? Right now, maybe we know more about Mars than the underwater. That's a fact. Some disruption is already beginning to happen. I don't know if you heard about this Kickstarter company, iBubble. They already make a drone. You can bring drone for diving. There could be some commercial applications as well. So underwater robotics may not be only for research purpose, but it could be some commercial applications as well. Talking about artificial intelligence, I fully agree with that. We begin to see the benefits of artificial intelligence. I really hope to see one day we have robots which can identify what is an organic object, what is a man-made rubbish underwater, so that we can deploy many of them to clean up the ocean. Right now, the ocean is in a big mess. Right.
I still believe in technology. What do I think will be disruptive in the future? I'm just kicking off a project right now that I've been working on for many years, and Hayato actually was an early part of the discussions on it. And that is an AUV that is self-deployable at rapid pace. So what I'm trying to do is for a suite of missions to get rid of the ship and the crew. And I think that changes the economics of things and the environmental impact. We don't talk about ships as working in gallons per mile. We talk about, or miles per gallon. I mean, we talk about the other way around. It's gallons per mile. So CO2, fuel use, and so forth for a ship is massive. And the number of people it takes and the maintenance it takes for a ship is huge. And if you can change those economics, that's disruptive, but probably in a good way. So I think there's and also the majority of missions for AUVs. I mean, there's a ton of them out in the open ocean. But really the most critical work for humanity is coastal. So something on the, maybe 60 miles out or something like that. I'm not sure what the number would be, but then once you get that kind of system going, you're going to, of course, build on it and advance it and that kind of thing. So I think there's a lot of disruption there that will come in terms of the everyday applications other than shipping. And in fact, even shipping might change. I've just seen something recently that along my lines of thinking is coming along too in Northern California.
I heard that the homogeneous vehicles, and I heard that the multi-domain types of vehicle will be, I think, will be really near future. It will come to the real operation, I believe. But for that purpose, of course, the very low bandwidth communication and also how the vehicle will identify the things automatically. So, and then how to say? Maybe my English is wrong. No. My vision is that imagine that there are many small autonomous vehicles at the beach or in near shore, and then if somebody get drowned, so the vehicle automatically go there and save somebody, or do some, if some bridges cannot be seen beneath, right, islands, and then always some vehicles are searching and detecting, or even can use non-detective testing, and then always search that how structure is healthy or not. That kind of technology is also we need. But always, how to say, the robot or vehicle can help or where the people are difficult to approach there. So, but imagine that the drone is grow up very rapidly. So we always think that that will be possible by us. Right?
Thank you. Yeah, I don't know if you recall the slide that Roland showed with the empty box on 1 to 10 kilometer scale. in terms of sampling the environment. I have a similar slide with an empty box which bridges between single vehicles and swarms, which I think we pretty much know how to do single vehicles, and that technology is fairly mature, and swarms are cutting edge research. I think there's a lot of value to be obtained by 2, maybe 3 at the most, collaborating vehicles with complementary functionality that are designed as a system from the get-go, not just glued together at the last minute. And what I mean by that is something like a surface vehicle and a subsurface vehicle, or a profiling glider and a straight and level flyer. They can provide complementarity in both communication, navigation, sampling, and everything, which is really, the total is more than the sum of the parts. So I think, in my view, the next big leap on the going from individual vehicles on the path towards swarms is the vehicle pairs, including in-the-air drones, or triplets, that are really designed from the start to work as a system, not just, kind of put together, and you throw the whole thing in and it boots itself up and performs whatever function you want it to perform. So that I think that's one area that is needs more research.
Great. So in fact, if I were to summarize, there were at least a few points that came across again and again in the discussion. And one was the need for multiple vehicles to work together and to have more intelligence. The other is for the vehicles to be able to communicate with each other. So communication becomes a very important point. And as we talked about, wired communication seems to work much better than wireless communication, right? So a natural question that comes from there is, well, what is an advantage of a AUV rather than a ROV, where you have wired and you have great communication? So why not just use ROVs? Tom, do you have any thoughts on that?
Well, my answer to that is an ROV has a tether, and on the other end of that tether is probably a very expensive platform with a lot of highly trained operators and probably a ship that costs $50,000 to $100,000 a day. But for some purposes, it's what you need. There's no universal solution for anything. I mean, if you need an ROV, if you need a big truck, you need a big truck. Don't get a Ferrari. And if you need to get somewhere fast, get the Ferrari. But I mean, there are certain missions like surveying large areas and sampling regions of the ocean that you need to do. ROV is not an efficient way to do it. If you need to do work on a subsurface structure or something, then an AUV is not going to be what you want either. So I think they're complementary technologies.
I agree. Anyone has any more comments on that?
Right now, those domains are actually changing quite a lot. Last year I gave a talk here about autonomy versus AI and when they cross over and so forth. And in that, I used a slide that you've seen many times with Jim started, I've expanded on, where the autonomy is moving into the realm of ROVs, and that's pushing out the manned vehicles and that kind of thing. But if you look today, there's several vehicles out there that are ROVs and AUVs at the same moment. So they can use the tether or be uncoupled. And that's becoming a very common thing, and industry, particularly oil and gas people, are really starting to look into that. So some of the science people and others have done that already. So that hybrid type situation is on us right now.
So in some cases, you can have tether in communication is of course much easier with tethers. But there are a lot of other cases when you don't want to have tethers for some reason or the other, either because it could get entangled or you have a ship at the other end of the tether, or for many different reasons. So what are the kinds of technologies that are available for underwater communications where you could reliably use these in different conditions? So Hayato-san, I guess you have been doing a lot of deployments. What kind of underwater technologies do you use for communication between your vehicles?
You mentioned the reliable communication. I would say unreliable communication in underwater, but how to tolerate, unreliable things is the challenge underwater, I think. But not only a communication, but at the same time, using the time of arrival, we can do a triangulation to communicate each other so that can locate each other at once if you use a communication in multiple vehicles in water. That's very useful too. Yeah.
So do you use mostly acoustic technologies? Do you use EM-based technologies? What do you use currently?
Acoustics.
Acoustics.
Yeah.
Any of the other panel members who have experience with other kinds of underwater communication technologies?
We tried laser once upon a time with a joint project with Hong Kong Polytechnic University actually. It's pretty impressive. You can send really large amount of data provided that water is crystal clear.
And what kind of distances did you do that over?
As long as they can see the laser beam. There's no limit actually, as long as you can see each other.
So there would be few tens of meters, I would imagine.
Yeah, but you can transfer video.
Yeah, sure.
Unfortunately, one disruption is enough.
Absolutely. Right. Now, going to a lot of the vehicles that some of the participants had, some of them use technologies like ROS, other people use custom-built technologies. Bill, do you have any experience with using ROS, and do you have any comments on ROS as well as alternatives to that that are there in the underwater robotics domain?
Well, there's so many of these things come along so fast, you know that. ROS is obviously the current champion out in the world. But the good thing about it is, and what I've watched happen in the last number of years, is we used to have to use a real-time operating system. So very expensive software and very key programming was required. Now you can use a regular computer and a clock and get away from a lot of that. So the computer chips are so fast, and ROS being open source is
actually on the vehicle. And a problem that many of the students seem to face is not all sensors are available in all the countries. And so what are some of the options that students might have if certain sensors are popular and they're available with drivers for ROS and things, but those are not things that are easily available in their country. So do any of you have experience in dealing with these kind of scenarios? And what kind of advice could you give our students here?
Well, I suggest try to find sponsors. Companies, they are in a good position to make import and export. So they can bring in components. And the components we are using for this competition is not really that expensive. Right? You can use a simple depth gauge. It doesn't have to be so complex IMU. You can use simpler sensors. Try to compensate that with your software. How you can improve your software, make it clever. But the quickest way to get these components, I suggest find local companies, find sponsors. That's the best way. The second way is to look for your alumni. We get a lot of sponsorship from our alumni, especially if your institution is quite an old and established one. You can look for your alumni and get their help.
Sorry to keep taking the mic, but I thought you said about a country where they couldn't get certain sensors. Okay, there's several things to do there. One is, if you have Google, you could probably learn how to build your own sensor. One of the things you can do is break it down into components. So many times the integrated sensor is not allowed, but the subcomponents that make it up are. So you have to do some labor, but it has to do with export-import laws depending on any country. And so, you know, and the other thing is, let's say it's an American product for some reason, you can't get it. But frequently a European or somebody else will have it and sell it to you. Or even, you know, a lot of the products go into India, and you can buy it from India, from all these places and things like that. So look around at your market and think outside the box. That's just talk.
Yeah, there's nothing that says you can't partner with other teams from other countries. We had a team that amazed me a few years ago that had entered the RoboSub competition. There were 3 partners, one from Australia, one from China, and one from Europe. And they had never physically seen each other until they came together a week before the competition in San Diego. Yet they developed the vehicle before that, pieces of it. You know, one group was writing the software, the group was doing mechanical stuff, the group was doing electrical stuff. They had a plan, and they budgeted some time beforehand to come together and actually put it together. It was amazing to me. That was the first, but that's another way to approach this. I mean, the guys who have access to some piece of hardware, you partner with them, and you know, most of the autonomy stuff is all software, so you don't need to be. You can do a lot in simulation. You can do a lot in simulation.
That certainly is a very inspiring story, and something for our teams to take away, that you can collaborate with each other. Although you may be competing here, there are things that you can share, and the bigger point of a challenge like this is to learn from each other and share, and not just the competition part of it. But I think one of the biggest sensor that a lot of teams have problems with are navigational sensors. So it tends to be the IMUs and DVLs, which are either too expensive, or the cheaper ones are ones which are not very accurate or stable. So do you have advice for the teams in terms of what they can do as alternatives, or whether these sensors are important for them in order to achieve the kinds of tasks that we have in the competition?
Well, that's a good point. Navigation is a fundamental issue, and I think one of the things we could do is, on our side, the organizers' side, we really haven't enabled the teams to implement easily things like SLAM algorithms, where you can self-localize and navigate on features, because we haven't provided the features. There's not many features in the pool, though there's a lot of black lines on the bottom. If the tasks were set up to be able to exploit those, you don't need a fancy IMU. You got a black line. You know, the bin is at the end of the black line. That's all you need. You need a cheap camera. Same thing you could do with a sonar, or a cheap sonar fish finder kind of thing. If there was bottom topography, or there isn't a pool to a certain degree. So I think a lot more could be done on our side. I wanted to push that, because it goes a little bit more toward the mapping function that we really haven't, exercised much.
So do you reckon that with a competition setup like what we have at SAUVC, you have a pool with tiles on the bottom, so you get lane markings and you get tiles. Could that be used successfully for odometry?
I think it could, or we could certainly doctor it up a little so that it could. I don't know, the pool managers might not like that, but, a black tile once in a while.
Power consuming, but you can do a structure from motion real time might be solution too. But another thing is that I would like to see here if somebody used just acoustics to vocalize in the pool, just using a simple transducers. That will be amazing.
Well, I told you guys I like optics. That's one of the things I've done. Done a lot of things with very cheap lasers. So these little pointers you can use in the room here. If you can, I had a project with some graduate students where we were asked by a scientist to go down one of these IODP boreholes. So there's these international drilling program holes all over the world, and then the walls break out, especially where there's like flow of the walls and so forth. And they wanted to go down this hole and map it. And so we calibrated a small cheap camera with a pencil laser, and all these things, and just had it spin, right? And then the data points moved based on the calibration. You just put the data points into MATLAB, and we made a three-dimensional image of this tube. So I could imagine, like in the pool, you kind of you're driving forward and you just go a little slower. You stop every so far. You have a little scan of the laser. You get a reflected dot off of your gate that gets added up in MATLAB or something on your board, and then you know where the gate is relative to where you're at and your altitude from the bottom. You probably could get pretty far doing something like that. Very, I don't know what those pointers cost, $20 or something like that. Your computer camera that you're already using, most of you guys have got in your vehicles already. So there's a lot of things you can do by stretching your mind.
I will say use camera. As a computer vision person, I will look at there's enough evidence for you to navigate if you don't have IMU.
As a computer vision person,
Yes.
do you have any comments on LiDAR technology? Because that's another technology that people have been talking about using underwater, but haven't seen a lot of its use yet.
For this competition, it's really expensive.
But in general.
Okay, this problem with the underwater robotics, right? You have a basic computing unit. How much memory you can put it there is a challenge, right? Having a LiDAR and all these sophisticated sensors means you need fast processors, memory space, and things like that. So there's pros and cons. Whether you want to make your hardware more expensive, if you can afford it, why not? But for most of the applications, I can say the computer vision, and especially with the AI coming in quite strong, you can do a lot of things.
And I guess there are a lot of computer vision libraries which have become common. So ROS has a lot of it built in. You have things like OpenCV which allow you to do a lot of things. So the barrier to entry to get something done is probably very small now.
Yeah, agreed.
I'd like to share one real example that appeared in one team in our competition in Japan. And there's a buoy touching, like bar, golf ball, And then I give them many points that if you minimize the weight of the vehicle. So the team come up with this very small, tiny fish-style robot in this size. And that has a very simple, tiny camera. And on it, DSP peak or something, or very low power. And it literally track the ball to hit it. And they won.
Right, so I'd comment on in two respects. Number one, you're doing a competition, so I think trying to buy expensive stuff defeats the purpose. So I think you can be more creative if you try to work around the challenges of the sensors you're trying to get. So I would really advocate not to get the worst sensors possible. You try to get common ones that are very affordable, and try to work with the trade-offs and the challenges you have with them. Now, second is related to my work on swarming still. I told you that the economics is actually important, because when you try to make many units, you cannot afford to buy an expensive sensor. So we have, in the research, we have been facing that problem. It's always very, tempting. You are online and you see these beautiful sensors and like LiDARs, they're expensive. And we always try to look the other way, right? If anything is expensive, don't buy it. Why? Because it might be completely useless and we might buy 50 of those. That would be a waste of money. And so I would, and also argue that when you have multiple vehicles and when you look at animals, for instance, they don't have always like perfect sensors, but when you integrate the information from many, many sensors, then you reduce a lot, the error that you're making on one data set. So there are ways around that problem.
Well, so one of the big questions is, if you look at, let's say, a mobile phone or a laptop nowadays, they are just filled with all kinds of sensors, and they can make them cheap, and you can have a mobile phone with a IMU and GPU and whatnot for a few $100s. Whereas most of these sensors that we see that are used on AUVs tend to be really expensive as compared to this. Any thoughts on why this is the case, and would there be a possibility of repurposing some of the cheap sensors that have been developed for other applications and use them on vehicles in an effective way?
A number of people have done that. They just use a cell phone as their guidance system. I mean, they just put it in the box and use it. There was somebody here, I don't remember which team it was now, but I thought it was pretty cute. They had an air sensor and they put a little diaphragm over the front of it for pressure. So that's great. I think that's awesome. So there's all kinds of things. One of the things I see in Japan, I've been there for robotics competitions, is they tend to look at the environment, and they frequently implement elements of what other animals do as their sensor system. So whiskers or things like that. So they set distances by and touchy-feely things, and they're quite simple. Just this one hit, that one didn't, so I'll go that way. So I think there's lots of things like that, and the data transfer stuff. We do it all the time at Embari. We call home with a phone.
Well, the answer to the cost question is just economies of scale. I mean, anything that's made in small quantities is going to tend to be expensive, and vice versa. So one strategy which we've always used for ocean stuff, because we never have that kind of scale, is to look for things that do. Anything made for a car, sensors, accelerometers, for example, cell phones, like Bill mentioned, anything that's made for, display. Why are the small brushless motors so cheap? Because of disk drives. Lithium polymer batteries, wasn't driven by the ocean community. So we've been capitalizing on those kind of things for years, and that's you have to keep doing that if you want to stay. You can't buy stuff that doesn't have those scale because it's just too expensive. And like Bill says, it may not be available because the markets are small. So.
Well, I think we've been talking quite a lot about sensing and navigation, but we haven't talked very much about control of the vehicles yet. So one of the burning questions that seems to be on the pigeonhole is what type of controllers can be used in an AUV when you have external random disturbances, and how can such disturbances be modeled? So in a pool environment, not so many disturbances. Maybe you have some of the filters and pumps working in the pool and divers swimming around. But in the ocean environment where you have currents and many other disturbances, this would obviously be a larger problem, and I'm sure many of you have experience dealing with it. So do you have any advice for our students?
Well, it depends on the vehicle. So I'll give you guys a story. One time I was in Sydney, I created the AUV tutorial that's done for IEEE. And I was teaching in Sydney, and two guys came up to me. They were from the NATO lab in Italy, Sia Marie. And they had one of the bluefin vehicles that has the tail cone, that I developed. So they came up to me after the class and they said, you know, this thing sucks. It's terrible. So I took them aside and asked them a few questions, and what it came down to was they hadn't ballasted their vehicle correctly. They were fighting themselves. So the number one thing in your systems is to understand the vectors and where your forces are going through the CG/CB, and then you'll create tons of stability right off the bat and save yourself a problem. So most of the problems you're going to have in disturbances are because of not paying attention to your weight and balance. That's the number one problem I see. And then there's some very easy ways to know when you see that if it's working or not. But when it's disturbances in the environment, that's actually not that big a problem most of the time. When these vehicles are in the water, they're flying in a mass that's moving, so you don't really know about most of the disturbances to begin with unless it's very turbulent. So it's not really that big a deal for us most of the time. We're usually our own worst enemy there.
Well, I'll tell you another story. No, actually, well, I've been an advocate of adaptive sampling for decades now. That's why I developed all of the small vehicles, because to do adaptive sampling, I'm with Roland, you need a lot of vehicles. I mean, the ocean's big. But I was shocked at one time when I had this workshop with a bunch of vehicle developers, especially the guys from industry. Because, I mean, what is adaptive sampling? That means you are letting sensors that are sensing typically the environment of some sort to take control of the vehicle. And I just thought, oh, yeah, sure, why not? Well, there was a major war in this workshop between the guys who said, there's nobody going to take control of my vehicle except those navigation sensors, not your temperature sensor or your salinity sensor. Something. You know, I'm not relinquishing control. And it was, I mean, I was not expecting it at all. I mean, I couldn't bridge the gap. You know, one set people, well, that's the way you do adaptive sampling, and the other people. Yeah, well, not with my vehicle. You know? So that's an interesting issue. If you want to do adaptive sampling, which I believe you do, you have to build in some flexibility into the control system, and you may want to limit that to in certain ways. It requires some thought, but I really wasn't expecting this backlash from the
Yeah, I absolutely agree with that. In fact, it's a similar experience as what we have been having in some of the cases, especially for deep sea missions or so, where understandably the people operating the vehicle don't want to relinquish control of what the vehicle is doing and let it do things. But that really is what we are talking about when we talk about autonomous underwater vehicles, that they're meant to be autonomous. Right.
This also brings up another thing that's happening in industry for you guys. Autonomous sampling is becoming quite popular now. So the mapping geology guys don't like it, but midwater stuff and whatnot, following gradients and that is happening. But the one that I think is funnier is this is actually in England. I won't say Southampton, but it's them. They were doing a science mission up in the Arctic, and this one just killed me. They had to go through a whole analysis with the university about the probability of loss of the vehicle to do their science. And they got shut down because the probability was too high at 90% survival rate. I was like, you gotta go, in America, our opinion is if you don't want to lose it, don't put it in the water. So I mean, the polarization there from thinking between two countries was just amazing to me.
Well, you know, the sequel to that is that's why most of the big vehicles developed by the U.S. Navy are not being used, because no one would ever take the chance of letting go of them and trying out the autonomy, to not on my watch kind of deal.
Well, in fact, I guess that points to the same direction we have been talking about, which is the vehicles need to be low cost individually so that you can afford to lose a few vehicles and still have a robust system that functions. Right. So in terms of both actuation as well as sensing, in order to go low cost, one of the arguments I've heard from many people is to look towards nature and towards biology and how have animals done this and to learn from it. So do you have any thoughts on biomimetic vehicles? Right.
Actuation using biomimetics things?
Both actuation as well as sensing using biomimetic ideas.
Actually, I'm not doing the biomimetics, but I was so much inspired of fish that you mentioned that the lateral line things, how fish are using. But we usually use how take out things that measure the distance to the wall or something using sensors. But the fish are not. Some different sense that they can locate or keep some distances. That would be might bring some new usage for the vehicles in water, reacting or some using the sensor information, reacting and form some behavior inside that.
This is a big thing. I've been working when I was back at MIT. I was working on how blind cave fish can essentially sense the environment. So for those of you who can look online, you have fish in caves in Mexico. They live in the dark. They don't use their eyes at all, and they can move very fast, and they can detect obstacles, and even more beautiful, they can detect the shape of an obstacle. So scientists have made experiments, if you have a triangular shape, or a circular shape, or a square shape, the fish are capable of mapping the environment, knowing exactly which column has which shape, and at what location. And if you change that, the fish will detect it. So they use pressure sensing. Now, if you try to mimic that, then you're really in big trouble, because you realize that, nature is beautiful, but then the kind of precision you need, the kind of sensors you need, we don't have that yet. And on the top of this, there is the additional part, which is the learning part. The fish is using its brain to compute the data in a way that we don't know. We don't even know what kind of representation of the obstacle they're using. So there's still a lot of work to do. So great source of inspiration. A lot of work for us in academia, but still a long way to go, I would say. On the other hand, I will also advocate, I see many groups that are really trying to really mimic or copy exactly what nature is doing, and I think we have access to technology and things that does not exist in nature, and we should not really stick to solutions that are found in nature. Like, let me give you an example. We're talking about communication. If you look at the school of fish, the communication is extremely short range. Right? They don't have access to any other means of communication. Maybe in the future we will, using lasers, using other ways. So there are some technical solutions that are not in nature, but are very innovative and potentially, can be interesting. So I think biological inspiration is good. Really copying nature can be quite a challenge, because there are so many things we don't know.
Well, absolutely. In fact, that's why in posing the question, one of the words that I used was bio-inspired rather than biomimetic, because biomimetic would suggest you just blindly copy, whereas bio-inspired is you try to learn from it, and maybe you re-engineer the solution to suit the kinds of sensors you have and the technology that you have. Arkan, do you have thoughts on it?
Well, all along I was thinking about what I read about these mantis shrimps. As a computer vision person, again, their vision is amazing. They have hundreds of lenses. At any one point of time, they are focusing with 3 lenses. So they can see the prey a lot more accurate than any other animal. And the other interesting thing that I read about them is the color spectrum they are seeing, we cannot even imagine, way beyond us. And the most important thing is they process the data directly in the eye. So it doesn't even go to the brain to detect the pattern. So that is really amazing. So that indicates maybe we can do some parallel processing in our ROVs or on AUVs in future?
And I've thought about this a little bit in the past, and one of the things that I'm not the person to do this, by the way, maybe one of you guys are, what animals or people can do that we don't really do well with computers is focus. So we can quickly focus attention. So if I'm looking at you and you're talking to me, I can see peripherally all the people in the room. I can hear people coughing. I can see motions and so forth, but I don't pay attention to them. They're filtered out very quickly, and I have an idea of what I'm looking at and want to do. What we do in computers is we make everything into big blocks, but we deal with all the data. We don't know how to drop that off quickly. And that's the kind of technological advance I think we need to make a big leap forward in this kind of an area where somehow your sensors, you want to focus on an area, and the other stuff is fuzzy. I don't know if that makes sense, but
Aspects with the powerful sonar as opposed to a vehicle that's just mapping with a side scan or multi-beam or something. You get what you get, but they go and look at it from every angle that they need until they figure it out very quickly. So it's a combination of the sonar and the platform that has a lot of maneuverability and feedback. There's a feedback loop there, which you could mimic. You don't have to make fins. You could do it with thrusters and stuff. But the idea of looking at things from different angles with high-resolution sonar, you get the effect. So that's a good example, I think.
Yeah, that's a wonderful example. Just following up on what you just said, where you could maneuver, which is important, but you could maneuver using thrusters instead of fins. However, if I pick up literature on biomimetic propulsion, almost every paper would say, biomimetic propulsion is so much more efficient than non-biomimetic propulsion, yet we don't see that many vehicles out there which use it. Why do you think that is?
Well, look at the actuation and see how long it lasts, whatever the simulated muscles and, whatever they're, you have to do that. You have to, millions of cycles. It becomes a materials issue in many ways. You're trying to emulate your tendons and, there's elastic parts and I think it's hard to keep it being reliable for a long period of time. That's my feeling.
Well, then the converse question to that would be, why didn't many animals evolve propellers?
Yeah, why? No. Slip rings, I don't know.
So, I think I have an answer to your question. Is that I think these people writing those papers, they don't make things, right? They're going to make a computer simulation, right? They're going to use CFD and so on, and they're going to show you this is more effective than that. But they don't go to the lab and actually make a device with actuators. Yeah.
I think the problem is that they're telling the truth, but they're telling the truth at the outside skin to the fin, not the muscle inside, which we can't imitate. So it's back to him with the actuator can't imitate the efficiency of the muscles and so forth, and how that wave of energy goes through. So, but maybe that will happen.
They also don't power it with sugar. They don't do the whole system.
Agreed. I think many of the students here have been interested in getting into the underwater robotic industries. But one of the questions that seems to pop up quite often in many different questions in Pigeonhole is, how do they go about doing this? Is there a good way for students to enter the industry? What are the opportunities that are available? How do they find these opportunities?
There's a lot of ways. I would say the best thing you guys can do to get into industry is to look for internships. The big companies, almost all the science institutes, certainly Woods Hole and Bari, they have internships. That's the first place. Then you get into apprenticeships or something like that with oil companies, that kind of thing. I was saying earlier about OES, they have a job posting site, but at the end of the day, your best deal to get into the business is to network. Who you know and what they know about you is you know, as harsh as that is possibly, it matters. One of the things I learned as a manager is that when somebody recommends somebody to me, right? So say Tom says, hey, I know this guy, he's great. The guy he recommended will almost always be a better employee than somebody else. The reason is he won't make Tom look bad. The guy stuck his neck out for him, and they tend to stand up for their buddy. And so they work out very well. And so recommendations, personal recommendations out of your network are usually very powerful. So keep that in mind. And then the marine industry is growing very quickly. And it's getting bigger and bigger every year. There's going to be plenty of jobs for you guys. Don't worry about that part.
I just gonna add one more thing. Whatever Bill mentioned, 100% true. If you have a good network, you achieve 50% of your target. But this is the time you need to be proactive. Maybe with this competition, you already start getting into this underwater robotics vehicle universe. Keep looking for conferences, associations, join IEEE. This way, build up your portfolio before even you graduate. From there, you will find links.
So I would just say that we have been polluting the ocean like so badly that essentially there is a lot of work to do. And I think at some point the governments will have to do something. And when they start doing it, if you guys are ready, not only you will be doing a good action for the environment, but on top of that you will bring your experience. So I think it's one way to kill like two birds with one stone. Yeah.
So you talk about applications in terms of cleaning up the oceans. What other applications are there? What kinds of industries could they look for jobs and applications in, where underwater robotics is either already important or going to be important in the future?
I can't speak for everything that's going on in the ocean. It's huge. But with the Ramon system that I've been working on a project with the aquarium for the last few months, looking at microplastics. So there's a huge plastics problem in the ocean. And the plastics are being broken down by the sun and the waves and so forth beating on them. And they're in the food chain. So they're getting into the guts of fish, and then they're collecting in the higher order fish and whatnot. And this has become a real concern. The same is going true for particularly places that had past wars. So off Japan, off Italy and whatnot, there's massive weapons dumps where at the end of the battles, they just dumped everything over because it was a big ocean. Who's going to go there? And now we're fishing deeper and deeper because there's such a demand on the fish. And they're starting to bring up old weapons that are corroded. So there's people getting chemical burns from World War II. I mean, there's a ton of issues out there to address, and that's just the little ones I know of.
I'd like to add one topic before. So, for students, I want to emphasize that you are showing a very big effort to make the vehicles, and I know that you have many challenges and trial and errors, and I think many faults or many failures always. But some may think that is like wasting the time or doing overnight, or why should I do this? But I believe that makes you strong and have strong mentality, and that is always, I believe that there's a very important point. Even if you get entered to the nice company, but if your mental is weak, you might be facing another issue. And I believe that this kind of a challenge for you is really work for you. And one of my students, that is real your experience, so you can proudly show what you have done to other people. And especially you made the company people and hey, I did like this. And if that is from your bottom of your heart, can that, how to say, impulse or something can move somebody's emotionally too.
Yeah, on the industry thing, you know, Bill mentioned this in his talk, on the conferences, it's not just the IEEE ones, but for sure in the MTS, OAS ones, but there are several other big conferences, marine conferences during the year. You know, there's two aspects to those. One is the papers and all, but then there's a floor with hundreds, literally, of vendors, companies. You just wander around down there. I mean, that's part of the networking. There's people at all those booths, and there's big companies and small companies. I'm always amazed at how many companies can stay in business. There's a lot, you know, because some of them are pretty niche markets, but they hang in there. And then there's very big companies too. You know, so boy, you could spend that whole week on that floor, and you could come back with a stack of business cards and leave a lot of your cards and talk with people that are doing everything from vehicles to batteries to sensors to services or survey things. I mean, it's an eye-opener. I would highly recommend it if you want to get not only a feel for industry, but start networking with industry. That's the place to hang out.
I also want to point out something. Most of these companies, even though you're engineers and your career is technical, they have tons of other positions that you might be interested in. So there's sales engineers, there's field engineers, you know, there's repair guys, there's installation guys. There's, you know, Amy's father's in the business and he does insurance, right, investigations and so forth. So don't think of it as just a narrow niche. Right, there's a plethora of jobs out there that and across the field of all kinds of things. Most of those guys on that floor, when you go visit the vendors at some place, most of them are engineers. You know, I mean, they've been in the field, they've done things, so there's a lot of opportunity.
So, are there any academic preparations that the students need to do to get into this industry? So, are there courses that specialize in underwater robotics, or what kinds of things should they be aiming for in order to get into these kind of industries?
I said it earlier in my talk, and I can't stress it enough. In engineering today, get that advanced degree and get your master's. It's just the way the field has gone. If you're an undergraduate, it's just not enough for most positions anymore. So they really want that advanced step.
Does anyone know? Do you know of specific courses? However, if someone wants to pursue further studies in underwater robotics, are there courses in the US or in Europe or in Asia that you know of?
I don't know about your universities, but where I teach, they have a special program where you can approach them in your junior year, sign up, and then they actually rearrange your program so that you can get your master's in about a year and a half. So I think a lot of schools are doing that now. So if you go talk to your professor or your counselor about making the arrangements, then you can make that as like just a flat-out continuation where you go through. We have it. Stanford does it. I don't know about MIT, but a lot of schools do that now.
I think at the end of the day, you might want to look, it's very interdisciplinary, right? When you look at everything you need in those systems. So you may get a degree that is more ocean related, or you may also just go into a program in just robotics. I would even argue that a master's degree nowadays is not even sufficient, because even a master's degree in robotics, you know, there are so many things in robotics, right? You have the controls, you have the sensors, you will have the mechanical design. There is really a lot to cover. So there is a wide range of programs that could be ranging from pure robotics to you know, ocean engineering, marine science, for those that are more interested in the biological aspects. But there is like, I don't think there is one particular program, but a range. So after that, it's really up to you. Once you join, a specific, say, degree in robotics, and you say, well, I'm very interested in everything related to the ocean, you will most likely find, you know, a project or something that is related to underwater, underwater vehicles or ocean engineering.
So there are many teams who have spoken to who develop initially technologies for their vehicles and then eventually feel that as the vehicle matures, maybe they should commercialize these technologies and they should have startups which would develop these vehicles. So what would your advice be to some of these teams? Is there a market opportunity for more AUVs in the market? Or are there maybe component technologies of AUVs which startups could potentially focus on?
Yeah. Well, I don't know how many times I've heard over the years, you know, I'm going to make a low-cost AUV. You know, these are way too expensive. Shouldn't be that expensive. I agree. They shouldn't. But you know, your car is way more common for $10,000. What they don't tend to appreciate is what it takes to run to be a viable business. It's a lot more than just, you know, building something out of components. You know, when you have to start accounting for time and effort and overhead and marketing and everything else that takes to run a business, that's why at the end, and I've seen this, I can name the vehicles, I mean the companies, the price is $100,000. It's only going to be $10,000 to begin. Say, well, what happened? Well, I became a business, and so that's. I wouldn't discourage anybody that wants to try it, but do it with your eyes open. I mean, any new business, and forget underwater. Anybody that'll tell you that ever started a company that it was way more work than they thought. You know, it was a huge amount of time, effort. You know, to get it going. And if it's successful, there's a return on that investment. But 80–90% of them are not successful. So. But you know, if you can make it happen, and there are examples of successes. So it's a small market. There's no doubt.
So in fact, I remember one of the reports, market reports that I read maybe 4 or 5 years ago, which was looking at what the AUV market globally is going to be like by 2020, and the numbers they were talking about was something like 400 vehicles a year, right? So you divide that by the number of companies that already exist. That's not a lot of vehicles. But if there were disruptive technologies which could make vehicles be useful for other applications that have not even been considered, is there a potential to grow this market rather than just approach the market that is currently there?
Absolutely. I think there's a ton of things going on that you would want to automate. So, for example, the crab fisheries in Alaska. I mean, if you could automate that, the lives you'd save, the costs would be reduced and so forth. And I think robots are capable of that when we get down the road. I'd like to step back, though. The concept of a cheap vehicle, and actually it was Tom's comment that made me think of this. You know, a car back in the 50s was not that expensive when you look back at it. It was at the time. A car nowadays is much more expensive, but there's a big difference. In the 50s, right, you would go out of your way to bring water and all kinds of stuff with your car to drive across the United States. Nowadays, I take a 20-year-old Honda, jump in it today, right, with 200,000 miles on it, and I'll drive to New York, never even think about it. So that's a cheap car. So the point being is, there's a lot of marketplace for AUVs if you think of it in an engineering sense of economics, not the absolute cost, right? So like my vehicle I want to build right now removes the ship. That's a big game changer in that single launch. They could also be swarmed once they're, there's no reason they couldn't be swarmed, but that one vehicle not needing a boat and people to get it out there, that it pays for itself in days.
I just want to add one more thing. If we look at it only AUV and a Kickstarter or business from AUV, maybe not so big business, but if you focus on application, maybe there is more opportunity there. For instance, there's fish farms. What can you do with autonomous vehicles for fish farms? That can be a business. Diving industry, what can you do for that? So maybe focus should be more on the application, then it can produce business ideas.
Well, we've been talking about some of the big picture items in terms of industry and education, what students can do. But I see that there's some of the more specific questions that are bubbling up on my pigeonhole list. So one of the questions is, how do you deal with inaccuracies in weight distribution and positioning of thrusters? And I think this comes back to one of the points that Bill made earlier about some vehicle not having its buoyancy right and fighting it and so on. But I also see a lot of the times, if you look at the literature, you would find, well, this is how you control a vehicle. If I have a great model of the thrusters and drag forces and everything, if I have a mathematical model, I know how to control it. But if I don't have a good model, what kind of control strategies could some of the students try out?
I wouldn't have a control strategy, I'd have an insurance strategy. If you don't have a good model about your vehicle to control it, you're taking a huge risk with your vehicle. That's the bottom line. The way we do it at Embari, because it is a modular, if you look at the systems that I did with Jim Bellingham and Tom, we have a file that reconfigures all the gains in the system based on the configuration. So you have to take a little bit of work for every configuration, check it out. We do have instruments that we swap out, but we make them absolutely the same in terms of CGCB. So when I swap them out, I don't have to change the gains. So we can get away with that in some places and whatnot. But yeah, if you don't have it modeled correctly and you don't have an understanding, particularly in AUVs, ROVs are so big for the most part that you can get away with some things. You know, we frequently bring ours back and the nose will be way down because we've collected a bunch of rocks. So you get away with that. In AUV, not so much.
So what about some of the trends in control engineering where people talk about adaptive control or robust control, which is robust to some of these kind of disturbances? Are those applicable or useful for AUVs at all? So the question basically was about vehicles where you don't know the model very accurately for control. What can people do about it, and would strategies like adaptive or robust control be useful in these cases to counter the fact that the model is not completely known?
Yeah, it's definitely useful. You know, I can give you an example from a few weeks ago with some Argo floats that we were deploying. Argo floats, for those of you who don't know, you go on the website, there's about 4,000 Argo floats throughout the ocean. And they're Lagrange floats. They drift at 1,000 meters for 10 days and come up, go down to 2,000, come up, report out their data, and then do it over. And they last for 5-6 years, maybe even longer now. So from a large-scale sampling, you know, that's a big network that's very valuable. But the point is that those are ballasted to go down to 1,000 meters, and there were some new floats that we deployed and they don't just go down and stop at that. You know, there's an overshoot. The control needs to be carefully done because they're not rated for full ocean depth. And of course, there was a little glitch in the software and everything again, of course. And so that's an example of and normally the control is adaptive. You know, it'll sense that it's gone beyond and then start to correct. And actually, the new ones learn from that. They self-learn. So the next cycles, they don't have this high amplitude of, you know, equilibration. They're pretty smart. And that's really important because as we just saw, if you don't get it right to begin with, you don't see them anymore. But that's an example, by the way. Speaking of economics, that's probably the only thing that even approaches economies of scale. Those orbital floats are still fairly cheap, but they're not. They don't motor around the ocean. They only have buoyancy control.
So for a lot of these cases where you want to get a model for your vehicle, making the measurements, especially if your vehicle is complex, may be quite hard. Are there any good software tools for simulating the mechanics of it, the fluid dynamics of it, in order to get an idea of how to control your vehicle?
A little different. For a small vehicle, I would say that just go ahead the system identification test using a tag. Just give any motions and you can have model. Or I would say the PID is pretty robust.
No, I agree. I don't want to say that you don't need a model, but some of the simple models, if you do a good system identification, are actually quite sufficient. So sometimes you don't need to have a highly accurate model. And the tendency is often to think that these softwares, commercial softwares, you can give them the CAD model and they will give you exactly, the center of gravity, the center of buoyancy, and you don't need to know all these details exactly to get a good sense of how your vehicle will perform.
Well, I think we are having our panelists getting tired. We have spent almost an hour and a half on it. I'm going to take one last burning question because it has much larger number of votes than everything else I have on this panel, right? And it asks us, well, how can you inexpensively convert an air microphone to a hydrophone? I guess the fact that we have a lot of underwater acoustic tasks, many of the students find that hydrophones are quite expensive to use. So are there any alternatives that you know of where you could have either cheap hydrophones or you could convert microphones to hydrophones?
I'm not sure I'd agree that hydrophones are still expensive. There are some pretty economical. We borrowed some a couple of months ago from one of the teams to do some more calibration, to gather some data in the tank, for simulation. And one of the guys working with them fried the hydrophones, so I had to buy some new ones for them. So I know they're not too expensive, a few $100. And I'm not sure converting a high resolution, one of these save much. And these things are ready to go. They're made for water, and there was 4 of them for a quad detector. So keep your eye on the market, fast-moving markets for these things. But, yeah.
By the way, do you guys get eBay or have something like that?
It depends on the countries that students come from.
I'm just saying, you won't believe the amount of stuff out there that somebody's trying to sell. And I'll bet you could get some hydrophones. I'm not kidding. It's like I go to YouTube and I want to fix a 52 DeSoto.
You should check Alibaba for how many hydrophones you find.
Yeah. Really, if you always want cheap sensors and equipment, these secondhand marketplaces and stuff, people are selling everything. Everything.
I can look up, I forget the name of the company, but I've got it. I can look it up and give you that's one. Yeah, there's probably others.
In fact, I agree with Tom. So one of my backgrounds is in underwater acoustics, and so we deal with hydrophones all the time. And while the idea of converting a microphone to a hydrophone may be an interesting one, for sound to get from water into air, where you have a very large impedance mismatch, you lose about 999 out of 1,000 part of the energy. So only a very little energy gets into air. So if you're going to put a microphone in there, it's not going to work very well. What you really need is something that's high impedance, like a piezoelectric, which is going to give you the transfer of energy in order to pick up enough of the sound energy. And there are a bunch of fairly low-cost hydrophones which are now available both commercially, as well as you will find papers where people make hydrophones for about $50. So you can pick up those papers, get a piezoelectric, which is not that hard to get, and encapsulate it yourself, and you should be able to make a cheap hydrophone.
Maybe just one thing. I will give an analogy. I have no expertise in acoustics and so on, but think of taking a drone and you try to get it to go underwater. Do you think it's going to work? But to me, it's the same idea, right? You have a drone which is meant to fly in the air, you know, given the properties of the air, given some aerodynamics, and then you try to get it to. So some people have been trying to work on objects that would be able to go underwater and then go at the surface, and it is extremely challenging. And the constraints you have coming from the two environments are such that I don't think that we will ever see a good object that will perform well in the water and in the air. And I think for, you know, it would be the same problem for acoustics. Yeah.
Yeah, before I forget, a resource that's available. One of the things that's a little different with RoboSub is the students have to write a paper, and there's the static judging phase that has a lot of points for things, but mostly for the paper. And those papers are online, you know, and there was, you know, 40-some teams last year, 40. And those papers typically describe all the components in the vehicle. They're including the, you know, ones that use hydrophones. So, you know, if you want to know what teams have been using in last year and recent years, go on the RoboSub website and start thumbing through whatever the equivalent virtually is of thumbing through those papers.
Yeah, I imagine that would be a great resource.
And you know, you'll come on some descriptions. And it's not just hydrophones, it's IMUs, the, you know, cameras, the other, whatever else they're using. Yeah.
Great. Well, I think the panels handled a lot of questions and given a lot of very useful advice. I just want to give the panel one last opportunity to say a few words where we may not have touched upon the topic. So if there's anything else that you want to add before we close the discussion session.
It's just been a pleasure to be here, and you know, I really I second all the comments before about staying encouraged. I used to give the, you know, kind of closing talks when I was funding the robotic thing, and I said the same thing every year, that if you're here and you participated, you're a winner, no matter who. It's not about money. It's not about, you know. I guarantee there isn't anybody here that didn't learn something. And if you learn something, you won. That's my simple thing. So I would think about it like that. You probably know more now than you did 3 days ago. So, you know, congratulations.
So I mentioned already, but what you have done are pouring effort, do the devotion for what you have done for the making some accomplish your vision, challenging or attending these things. Already you have a very big, you could obtain many precious things that nobody can break it. That is your, how to say, is it understandable? Yeah. Anyway, nobody can touch or nobody can break that you have obtained by your own effort. You have done so much effort that is very precious, and you keep going, and that will be fruitful in the future for you. Thank you, and congratulations, and you did a good job.
From my standpoint, I've been a part of coming here and helping out in terms of economics a little bit for now. I think it's 5 years. I can't remember. No, is it? I don't know. Anyway, point being is, would the crew stand up from SAUVC? All you guys. I want you guys to thank these people. I've been watching the AUV stuff happen in Asia. And it wouldn't have happened without these people. For you guys that are new and whatnot, you don't realize how big this has gotten from what in such a short period. So these guys are part of your network now. Make sure you get to know them. You can count on them to back you up if you have questions in the future. I hope you come back next year to the competition and bring some new teams along. This is great for Asia. And more than anything for you individually, it's a great experience that you'll carry with you forever. So take heart in that. And whatever Hayata said, I agree.
All right. Okay, as a host, I would like to say welcome to all of you. Thanks for coming to this competition. It's really growing and even growing out of our control, it seems. In a very short time, it became very popular. The important thing of this competition as an educator is the learning process. Really, experience you gain here is incomparable. Textbook stuff you will learn anytime, but once you put those things into practice, and especially in a project like this, you need to work as a group, as a team. You will learn teamwork, communication skills, which is very essential in system engineering and multidisciplinary projects. So I think this will be a very valuable experience for you. Put into your CV, put into your portfolio, that is very beneficial. And the other thing I want to say, thanks to our committee, really, they are doing a great job. Bill already said before me. All the best.
All right, nothing much left to say, but I just want to, as a professor, I just want to say, you guys are lucky. It's a great time to be an engineer. It's great to work in things related to ocean at the same time. Why is it a great time to be an engineer? Because you have so many things that you can do in rapid prototyping, sensors, computer softwares that would be a dream for most of us when we were students. And so you have access to all of these Raspberry Pi that cost $5, sensors everywhere, even if they're not perfect. So it's a great time to make things, to be an engineer, to practice. To go beyond the textbooks, indeed. So you have to realize this, and you have to do the best you can to, change things such that we can clean our ocean, and you guys can do that. So, yeah, well done.
Well, thank you. Well,